it's recording. Make sure this is all recording. It's good. Okay.
Does it switch audio sources to the record to?
Yep, it did. I could tell because the monitor is specific to the application.
Oh.
So FFmpeg is the application that I use to do the recording. So it's showing what the recording software should be seeing.
Yeah, sometimes in Windows, when you switch the audio device, it continues to go on the previous audio device until the application reloads connection.
Well, this particular program is pretty good. You can identify the application and switch for that particular application where the audio source is coming from. All right. So what we'll do today in the lab is to talk about the make utility program, okay, which is not really core to the concept of assembly language programming or architecture, but it is a very useful tool, and it would be useful for our homework assignments. So that's why we need to talk about it. And before we talk about the make program, what I'll do is I'm going to give you a sample program to illustrate the need of a make file. Okay. How many people have written programs where one single source file is it's going to exceed maybe, I don't know, 2,000 lines, and it's a good time to split it into several files? Not for your kind of homework assignments, right? What is the longest program that you have written for your programming assignments in 430 or
Several
400?
hundred.
Several hundreds,
Yeah.
okay? Not quite to the several thousand range, right?
I have. I have.
You have? Okay. So for very few people, just for doing homework assignment, actually has the need to split a program into multiple source files. What about, I don't know, Firefox, the source code of Firefox? Now, I have no idea how long it is, but I can always look it up.
It's only one line. Go to web page.
Okay, so I just need to know the number of lines. Okay. Here we go. Well, I think this is. Okay, I'm gonna open it up because I think it's a table, so I need to look at the table.
Good lines.
Well, it has grown over time. The total number of lines is 17 million something. Code line, which is just for code, which is what I'm really concerned about, is about 12 million. Of those, we have about 4 million lines that are not actual code because they can be blank lines or comment. So that would still leave us with what, about 8 million lines of code? That's actual solid code, not comment, not white space. And 8 million lines is quite a bit, okay?
It looks like if you scroll down, it'll give you a graph of
how it changed over time. Yep, there we go.
Oh, 2000, a little after 2007.
I have to shrink it. So it got up to here. This is March. This year it is 12 million or so. And just 3 years ago is only half the size.
Yeah, it looks like around 2012 it started to increase.
And there's a sudden bump here. From August to September, it went from 11.6 to 12.4 million lines of code. That's a pretty significant change over just 1 month of time.
And that's only the release version, right?
Yep, I think so. So anyway, so the point is, okay, for projects like this, you probably don't want to put everything into one single source file. Okay? Well, even if your editor can handle it, okay, even if your editor can open this file, which has 12 million lines of code, with no delay, it's just like opening a small file, okay? Why would it still not be such a good idea?
You would need to have like a dictionary for wherever it goes.
Okay, you can need a. Well, even if you break it up into smaller files, it will still be. You still have to have a way to kind of find out which source file contains the definition of which class or subroutine. Yep.
Yeah, even thinking about when you want to go in and edit to optimize something, moving back and forth would be a huge pain. Just
Yeah, it will be.
Trying to find where things are to all the different function calls and declarations.
Yep. But what about in the process of development? Okay, so let's say you are responsible to fix a specific memory leak. Okay, so the code in question, okay, for in your case, to fix that memory leak, let's say the range of code is about, I don't know, let's call it 4,000 lines. Okay, 4,000 lines of code that is a suspect chunk of code that you might have to fix. Okay, so when you fix a particular problem, and Mozilla Firefox being a compiled program means what do you have to do with the source code before you can test run it again? You have to compile, right? And if the entire program is in one single source file, every time you make one little change, how many lines of code needs to be recompiled?
12 million.
12 million lines of code. And do you think compiling is a quick process or a slow process?
Very slow.
It's a very slow process, especially when you turn on the optimization. So in GCC or G++, if you say -O3, it will do a lot of optimization, and your program can potentially run twice as fast as a result, which means it's kind of worthwhile when you're ready to release the code. But when you're not ready to release the code, sometimes it's just a huge waste of time. Okay. But hold on a second here. You're recompiling 12 million lines of code because of one change, and even if you consider the entire range of program that might contain a bug that you should be fixing, it's only 4,000 lines of code. So why are you recompiling 12 million minus 4,000 lines of code unnecessarily every single time you make a change? Doesn't make any sense. Okay, it does not make any sense. Okay. Okay, but somebody's going to say, but even if you're not recompiling 12 million lines of code, you will still have to relink the entire program so they can run. Well, guess what? The linker is fast. Okay, the linker runs much faster than compiler. That means if you can avoid having to recompile 12 million lines of code and just have to relink with the old code that has not been touched by your fix, you can speed up the whole process tremendously. That is one big driving force, a practical driving force behind splitting up a project into multiple source files. It's just so that if you don't need to touch a particular source file, don't recompile it. Keep its object code around, just relink it, because linking is a very, very fast process compared to compiling. So is that okay so far? Why we have a reason to not to put a program into big, huge files. Instead, we want to split it up into smaller files. Is that okay? Okay. All right. So once we get the rationale out of the way, all I can do in this class is to use toy smaller examples. I cannot give you an example of 12 million lines of code, but I can do something a little bit smaller. Okay. So what I'll do is I'm going to write a very simple program that has 3 files, which is kind of like your homework assignment. So I'm going to use -O here so I can split the screen 3 ways so I can look at all 3 files at the same time. One is main.c, one is Johnny, and the other one is one more. I'm going to use the same name as the source code. In other words, the name of the subroutine is the name of the source file, just so that it's easy to kind of come up with a system to do it. And obviously, all of these files are empty at this point. I'm just going to retype everything. In the case of Johnny, this is the prototype of Johnny. In other words, I'm just telling the compiler, if this program is going to call Johnny, this is how it should be done. It has no parameters, and it returns an integer. Without this, the compiler would not know what is the proper way to call Johnny, and that's why we need a prototype to tell the compiler this is the way to do it. Oops. Yeah. Open curly brace, close curly brace, and this part is not really that important, so I'll still do it anyway. Same thing as in your homework assignment. And I will need another prototype for one more. It returns an integer, and it takes one parameter, which is an integer. So you will have to do this as well when you work on your homework assignment. When you comment out the actual definition of a subroutine, which includes the open and close curly brace, you will have to substitute the definition with a prototype. which is just really just the header part here to tell the compiler how do I use this subroutine. Are we okay? Are we okay in terms of the concept of what is a prototype as opposed to what is the definition of a subroutine? Okay, if that's okay, the main program is done. Let's move on to Johnny. So in this case, Johnny is the actual definition, and it's just return 5 in this case. And save it. We can now move on to the last one, which is one more. One more is just about as easy, because all it does is to return x plus 1. All right. So now we have 3 source files, and obviously in this case there's really no reason to split it up into 3 source files, other than the reason of it just explaining how to get it done. Okay. So let's get out of the editor, and just do an ls. Now we have the 3 source files, Johnny, main, and one more. Without a make file, every time you want to create the executable, it's kind of a chore, okay? Because you have to find out, I just updated, Johnny. Now I have to do the gcc-g-wall-c johnny.c. Okay, what that does is it compiles johnny.c into the object file johnny.o. And then I have to do the same thing with main. Okay, here's main. It's compiled, and the last one is one more. Okay, thank you. And now we have 3 .o files, each one corresponding to one .c file. So the last process is to link the object files into the executable, which is gcc-o main.o, one more.o, and johnny.o. And now we have the main subroutine, or the main program, and we can actually do a gdb main. And this part may seem kind of boring, but it's actually kind of interesting, because now we have the source code split into 3 different files. So how do we go from one file to the next? Well, it's all automatic, because what we can do is to put a breakpoint on line 7, run the program. We're on line 7 right now. If you single step and the subroutine is in a source file that was also compiled with a -g option, guess what? It knows how to get there. Not a problem. And it will even switch back to main, like this one here. Okay, next step, it switches back to main, and now I can say, hey, what is the value of x in main? So that's kind of handy, okay? The other thing you can also do is you can set up a breakpoint in a particular line of a particular file. So you can say, I want to put a breakpoint on one more.c line number 4. Okay, I'm not even sure whether it's a good place to put a breakpoint or not, but it lets you do it. Okay. So this is how in GDB you can actually debug a project that is split between multiple files, and it's easy. Okay, it's not any harder than debugging a program that is in a single source file. We still okay so far? Okay. So if this is okay, then I'm going to pretend that I have one thing to do in one more. Okay, so I'm going to say go to one more, and I go look at this and go like, I want to change the implementation. I want to make this unnecessarily more difficult. Fine. Well, whenever I change the source code, I have to recompile this particular source code, right? So that means when I get out here, the first thing I really need to do is to say, oh, gcc-wall-g-c one more.c, and then relink in order to run the updated program. The question is, what if I forget to do it?
Just use the old object file, wouldn't it?
Well, I can. Well, remember there are 2 steps that I have to do. One is to recompile, one is to relink. If you forget both, it's one thing. If you forget one, it's still not going to work. Okay, I'll show you exactly what's going to happen. I recompile, and then I thought, hey, okay, I can run the program again. Now it will use the new code. Okay, let's see what happens. GDB main. Not a problem, it's still here. And GDB is not responsible to double check and say that, hey, this executable is outdated, you need to do something about it. It doesn't know. So what happens is, when I put a breakpoint in one more, that's not the issue. I run the program. I'm now in one more. Well, it does. Okay, it is a smartass. it says source file is more recent than executable. But if people ignore the warning and continue to debug the program, it's not going to work. It doesn't make sense. Did you see how it went back to main only after y gets x plus 1? That's because the line numbers don't line up anymore. The executable only remembers the mapping from execution location to line numbers of the previous source code. But the source code has changed. So it is just blindly going into line 4 of the source code and say, this is where we are. But that's not the instruction, or that's not the statement that we're executing anymore, because we have changed the source code already. The executable has not been changed. Yep.
Is that still reading the old object or the executed the new one?
The object file is useless because it is neither the source file nor the executable. So as long as the executable does not agree with the source code, it doesn't work. The GDB cannot work without that consistency. So you can say, okay, but that's easy to fix. We just have to relink the whole thing, right? So main Johnny.o and one more.o, and then we can GDB again. But how far along in the debug process do you have to go to realize, hey, something is not right? It might take a long time, okay? So that's the whole idea of why we want to have a make file. Because with a make file, every time you make any change to any source file, when you're done with that change, you go back to the command line. All you have to do is to say, make. Press the enter key. Everything will automatically get done to give you the most updated executable, and you'll be ready to debug. You don't have to worry about, oh, did I recompile that file? Did I relink the entire program? You don't have to do a single thing. You let make as a utility program to take care of that. Are we doing okay so far with the concept of why we want to have a make utility program to take care of all the dependencies, basically? Yep.
The make file, will it be able to know if you had edited one of the source files, so it knows whether to recompile it or not?
Yep, that's the whole point. What you do with the make file is you're expressing the dependency amongst the files that you're dealing with. Okay, so at the core of a make file, which is, I just want to point out where the notes is, and then I'll just go talk about it. This is the actual make file. You can download this one. The explanation is over here, more about the make program. So it talks a little bit about what the make file is and so on and so forth. But instead of going through my notes and just reading it, I can just talk about the concept of what you are actually telling a make file. Everything is broken down into 3 components. Okay, there are many things, but each one has these 3 components. It has what we call a target. Okay, a target is the thing that you want. Okay, or as an intermediate process, something that is needed. That's called a target. Are we okay on the concept of a target? Okay, a target has a list of dependency, things that is needed to make the target. Are we okay? And the third component are rules. Okay, in other words, okay, I understand that to make this target, I will need these components, but what is the process? What is the command line to do it? That's the rule. Okay, that's the third part. The command in order to take the dependency to create the target. Are we doing okay so far with that? Okay, as long as your project, regardless of whether it is a coding project, an HTML project, or whatnot, as long as your project has files and you can express the relationship, the dependency of relationships amongst the files, you can use the make utility program. So that means it's not just for assembly language programming. It's not just for C, C++ programming. You can use it in just about any situation where you have a bunch of files, they have some sort of interdependencies, and you know exactly how to create a target file from its dependency. Are we doing okay so far with that concept?
Is this for because of units or because of we use C?
What?
We have to link it to this step because our units only run this way, or because of C language required that we do this.
I'm not.
Because and the main we already call this file, so which means actually my source code already linked. If I use a lot of like IBM language, I don't need to link as long as I specify. So I just compare.
Are you talking about when you use a GUI, you don't need to do this?
Yeah, I just curious, is this required by Linux or required by C++?
The operating system has nothing to do with the make utility program. The make utility program is just what it is, okay? In text, you describe the dependency, and then you just say, hey, make, check to see if I have the most updated version of this. If not, make it happen. Update everything accordingly. That's what you're telling it. Now, if I understand your question correctly, you're asking, but code blocks or Visual Basic doesn't have anything like this. You just click a button and it automatically rebuilds everything, right? Is that kind of your question? Why do we have to go through this to?
I mean, why do we have to link it, make this process to link this file together, compile in different way, because we already link it, which is
Okay. Are you talking about the command to do the linking?
Yeah, I just am curious why.
Well, then my question is, why do you want to recompile 12 million lines of code when only 4,000 needs to be recompiled?
My question is, whatever how many files, but which is that required by what situation?
The make file?
Yeah, I don't need to do it. So I use a lot of language. I don't need to do this.
That is correct. A lot of tools will save you the trouble of not having to specify a make file.
Yeah, I just curious.
But as a sorry?
Because Linux required to do that.
Well, most utilities, including the Linux kernel itself, relies on make files. So if you want to work with a lot of the different projects, you understanding how a make file works is going to be very beneficial because there are no GUI tools for those particular projects. Okay? These are low-level tools, but nonetheless useful, really helpful, useful tools. Okay? All right. So getting back to the notes here. Now, if you want to express the dependency of this particular project, this is one way to do it. So you just say, hey, I want to express all the dependency. You start with main, and you say, okay, what does main depend on? Well, main depends on main.o, it depends on onemore.o, it depends on johnny.o. These are the object files. And then on the next line, using a tab as the beginning, you can now specify how do we go from the .o files into the .main? Well, it's gcc-o main.o, one more. Don't copy it because it's not usable. Johnny.o, and that's how you specify the three things that we were talking about. This is the target, this is the dependency, and this is the command to take the dependency files and turn it into the target file.
Is it the file sequence matter?
Sorry?
This file sequence have matter. I mean, if I put it to different sequence, there is that.
If you put in
different sequence.
different.
For example, if I put a Johnny before.
The order is not important because the
But
linker does not depend on it. Yep.
This doesn't create object files from source files, though, does it?
Oh yeah. Then I have more rules to specify that, right? Then the next thing I do is to say, well, in fact, let's see what happens when I do something like this. So we'll go ahead and remove main and all the .o files, okay? And I say make, and guess what? Make is going to give you a very reasonable message. Oh, I guess it does. Not. It has implicit rules. There's a whole bunch of implicit rules, so it kind of knows how to do it, even though we did not spell it out. But you are right, okay? This is not supposed to work because without the implicit rules, it would not know. Oh, but how do we make a main.o? But the implicit rules took care of that. So so technically speaking, you really should specify this as well, and say the .o file depends on the .c file, gcc-wall-g-o-c main.c will create the .o file. So technically speaking, we should have 3 things like this in order to make it work. Okay, but that is still a big hassle. Okay, that is still a big hassle to have to maintain all of this stuff here. And it gets even more complicated later on when we have header files. Does everybody understand what is a header file in C and C++ programming? So sometimes you create your own header file, and the dependency now gets more complicated because it depends on which .c or CPP file pound includes which header file that you create. What if you have a header file that pound includes another header file? You can do that. I mean, no one says you cannot have embedded or nested pound includes. Then it gets even more complicated. And then the problem is, what if you forget to express this particular .c or .cpp file depends on this .h file? If you forget to mention that, it simply means make will not recompile when you update the header file. Okay, which does not sound like too bad of a thing. But if you changed the definition of a structure or a class in a .h file, and you forget to recompile one of the many source files of a particular project, you get some really funky errors. Okay, all I can say is it's going to be something that you would not want to debug, because it's not necessarily a hard crash at the problem where it happens. It can be a memory corruption issue because things are just quote-unquote off. There's no consistency between the object files. So when one object file says, oh, I think member X of this structure is 5 bytes or 6 bytes from the beginning, the other one will misunderstand it to be 4 bytes from the beginning. So now when one object file is going to make changes, it will do it to the right place. The other one will do it to the wrong place. And hence, you will have mysterious corruption issues that is really hard to explain. Okay? So you don't want to deal with that. Yep?
How many times has it happened to you?
Quite a few.
I noticed by how you're laughing about that.
Well, but that's the best way to learn, is to run into a problem and go like, man, that sucks. How do I prevent it from happening again? All right, so getting back to the notes here, this part says, yeah, it works like this, it's tedious, but it's not really the best way to do it. And, I'm going to skip a few examples and talk about this one here, which is close to done, okay? And I'm going to use the one that is linked from Moodle. So I'm going to go to, where is it? Oh, I guess it's, go back, right here. So when you click on this link here, make file, what I'll do is I'm going to save the link into the temp folder, which is where the project is. Okay, and I'll replace the one that I have right there. Whenever you get a warning like this, you have to be really careful, because now I have a new make file. Wow, Tag, you said you would improve things. This looks more complicated than the previous one. It does look a lot more complicated. So I'm going to explain what it is. I'm going to remove a few things that is not related to what we do for today's class. So I'm going to clean it up a little bit, just because these things are not really needed. And okay, so I'm going to remove all the things that we don't need. Down here, that's gone. Okay, that's good. All right, so I'll explain this line by line. Line 1 is basically saying, okay, which is your C compiler? Now, CC in uppercase is what we call a variable. So make, as a utility program, also has a concept of a variable. You can define a variable and then just refer to it and say, oh, this is what I meant. Okay, so CC is an internally used variable for the C compiler. On the platform, you can have multiple C compilers, which does not seem to make any sense. Okay, why would I want to have another compiler on this particular platform? Well, for those of you who have done cross-platform development, you will understand, hey, What if I am using a Linux environment to develop programs that will run on an Arduino architecture platform? Then I will need a cross compiler so that the compiler runs on the PC, but the code that it generates will run on an Arduino platform. As a result, I will have multiple compilers, and they will have different names. So for each project, I can set it up and say, oh, with this one, it's a native application, I'll use GCC. The next one, because I'm compiling to the AVR architecture, I would use AVR-GCC as a cross-compiler. So this gives you this ability to specify which compiler do you want to use. Line 2 defines C flags, which is a environmental variable, which is just a variable. This one is based on an implicit rule, and it specifies whenever we are compiling, what are the flags that we want to include. Okay, and you can see that I'm including -00, which means do not have any optimization. I might be wrong here, so I'm gonna just. That is correct. Okay, so this turns off all optimization. -wall means warn all. Okay, nag me as much as possible, and then -g means include debug information. So whenever the compiler runs to compile source code into object code, all of these flags will be included, which saves me the trouble of, if I hand type everything, occasionally, as you have observed in class, I would forget to type -g. So by the time I get to GDB, it goes like, where's the source code? Oh, that's right, I forgot to specify -g. This way I will never forget. AS flags is applicable only to the assembler. So in this case, I'm including -g steps. The -g I think does not really do anything, so it can go away. CXX is for C++ compiling, which is not relevant in this case. I don't have to get rid of it, but it doesn't really need to be here either. Okay. LD flags is the linker flag. When I have all the object files and it's ready to be linked, this is the flag, or these are the flags that will be included. -g doesn't do a single thing to a linker, so this I can also get rid of this and not change the meaning of the entire program. From line 1 to line 4, these things for the most part are used internally. In other words, they are not used by explicit rules that I specify. Okay, they are used by something else, and I'll explain what that something else is. C source, okay, CSRC is C source. This is where the good stuff begins. You just have to list all the .c files in your project. Okay, so in this case, I have main.c, I have one more .c, and I have Johnny.c. So I just spell out all the C source code, and that's it. I don't have any C++ source code, so this will be empty. The name of the executable is main. I don't have any actual include file. We're way, it will be at least 2 more classes before we get to that part. And I don't have any assembly source code. So that means if you have any assembly source code, when you have implemented one more .s, you would put it here. You would take this one away and then put one over here. But since I do not have one more .s as a source file, this one remains empty. Okay, now what about the other lines? Yep, go ahead.
ASRC?
Huh?
What is the R for?
Source. Source. SRC is source.
Oh. I was looking at AS as assembly and AR as something different.
Oh, no, the A is assembly and the SRC is a source. But these are my own variables, so if you don't like the names, you can definitely change these. The first 5 lines you cannot change because those are used internally. So those are the names that the system is looking for, so you should not be changing those. Okay. But the rest of the code does not seem to do a whole lot. Okay, if you look at line 12, what line 12 is doing is expressing a dependency. What it's saying right here is whenever you see a dollar and a pair of parentheses, it's referring to the value of a variable. In other words, this entire thing, dollar, open, exe, close paren, is just referring to the definition or the value of exe as a variable, which is main. Okay. What about this part here? That gets a little bit more complicated because cisp310 is a list of source files written in C. So what is this whole thing about :.c equals .o? Well, this is one of the really useful tools in Make. It's basically saying, take everything in cisp310, change all the extension .c into extension .o. And it's a very, very useful tool because now you can say, oh, here's a whole bunch of source files, but in this case, I just want to list the object files. And you can do the same thing with .uppercase_s for assembly source code. Line 14. This one looks even more mysterious. This one is saying it's not even spelling out what is the actual target. Percent. Okay? As it turns out, percent is a wild card. It's basically saying if anyone ever needs a percent or whatever .d file, this is how we make it. Whatever .d has a dependency of whatever .c. In other words, if there is, for whatever reason, if there's a need of yada yada .d, this rule says, oh, yada yada .d would need to rely on yada yada .c. Okay, fine, but how do we turn yada yada .c into yada yada .o? Or .d, sorry. This is the command to do it, okay? So we have $cc, which is using the C compiler that we mentioned earlier. And then we specify, I have to move the cursor because it's interfering. We specify the tool itself, $caret. $caret is actually referring to, I have to remember which one it refers to. $% refers to the dependency, and -mm, -mf are just real options that you're passing to the compiler. Yep.
Sorry, why do we need a .d? Are we going to make a file with a .d?
Yep, yes we are. And then $@ is referring to the target itself. So this is basically saying, I don't know, I don't need to know the exact name. Okay, I just need to know if a file is needed, it has a .d extension. One way to do it is to find a .c file with the same file name, and this is the command to do it, to get it done. The same thing applies to .s. Okay, you can see the command is exactly the same. Okay, -mm and -mm obviously is the true magic of this part of the make file. Okay, we have a weird target called clean. Now clean is really useful because what it does is every time you say make clean, the make utility program will say, okay, let's go make that target. It does not depend on anything, and the command to create quote-unquote clean is to remove all the intermediate files that is not source. In other words, it cleans up your folder, your directory, to remove everything that can be created automatically by the tool. So just in case you run into any problem like a timestamp issue or some other problem, and you say, I want to start from scratch, which is equivalent to rebuild all, okay, in the tool, in a GUI tool, this is the way to do it. Make clean and then make again. So it is forced to regenerate everything from scratch. Are we doing okay so far? Somebody asked about the .d file. Line 23 and line 24 is the .d files. So line 23 and line 24 relies on the word include, which is kind of like a pound include. It simply says, well, pretend that these files is a part of the make file. So whatever rule is specified in these files, it is a part of the make process. What files are we talking about? Well, take the entire list of C source, which is main.c, one more.c, and johnny.c in this case. Replace all the extension .c with the extension .d. So this will force make to find, hey, where's main.d? Hey, where's main one more.d and where's johnny.d? That request, that requirement is going to trigger either this one or this one, depending on whether you're implementing in C or assembly, and that in return will create the .d file. So the big question is, what does a .d file look like? I mean, that's an extension that we have never talked about in this class. So let's go ahead and give the whole thing a try. So the first thing I'll do is to make clean, okay, to remove all the intermediate files. And in the process, it is already generating the .d files. Okay, see Johnny.d is now created, one more, and main is created. Let's take a look at one of them. Oops. Oh, I just created and then I got rid of all of those. Okay, so if I make again, it will first make the .d file, and then the .d file in return will generate the rest. Okay, so let's take a look. You can see this is the same process as we did earlier by hand, except this is a whole lot easier. I don't have to worry about single thing. But we do want to take a look at the .d file and find out what it looks like. So we'll take a look at main.d. This is the entire content of main.d. What does it look like? Doesn't that look like a single rule of main.o as a target, main.c as a dependency, with implicit rules to specify how to get it done? The implicit rule will automatically make use of cc, which is the name of the command line for compiling in C, C flags, which is what it will use when you are compiling. So it will implicitly make use of those variables that we defined earlier from line 1 to line 5 of the makefile. Are we still doing okay so far? Just the big picture, okay?
What kind of reason do we have to use .d?
To do what?
.d.
.d? Well, .d is magically and extremely useful because when you have #include to include header files, the .d files will automatically figure out the full dependency. In other words, if you have a #include of a header file which has 2 more #includes of 2 other header files, each one has 3 more #include to include yet more files, guess what? They will all be expressed automatically in the .d file. The -mm and the -mf option that we passed to GCC basically makes the C preprocessor report back the dependency on header files. So that's why it's automatically done, which is great, because every time you make any change to any source file, whether it's a .c, .cpp, a .s, or .h, including the header files, you just have to say make, and it will take care of everything for you. Okay, so let's go ahead and test it. Okay, well, main is obviously done here, so we'll go to main and say let's make some changes to it, just to force the make utility program to do something. And it doesn't have to be much. You can just say I'm inserting a new line here. As far as the timestamp of this file is concerned, it is now updated. Okay, and that's what make is using in order to figure out, hey, the source code is newer than the object code and something needs to be done. It will automatically figure that out. So once we exit, we say make, and it will first of all, because I changed the source file, the first thing it does is to recreate the .d file, because the one change that I did may be adding another #include. So it has to regenerate the dependency itself. Once main.d is automatically regenerated, the next line is actually making use of main.d to say, oh, okay, let's go ahead and recompile main.o from main.c. Well, once you update the object file, you have to update the executable, and the last line here is to say, let's go ahead and link all the object files into main as the executable. And it's all done. Okay, I will not forget to recompile. I will not forget to relink. This is all done automatically. Now, for those of you who are truly lazy, okay, and you say, well, sometimes I would make some changes, and I would go back into the debugger, even forgetting to remake. So make cannot save you from that, or can it? This is how I do it. Okay. So this is just a little trick that I use myself to do things. So what I usually do is I do it like this. I specify, oh, let me see. I can do it like this. I make a virtual, completely useless target called, in this case, this is equivalent to main.gdb because exe as a variable is just main, right? So we are basically saying the target called main.gdb depends on main, the executable. And then the process to create it is the trick, because we can just say gdb $exe. Does it actually create a file called main.gdb? No. But we don't care, right? As long as it triggers gdb to run with the executable, I'm good. If you want to specify, all the redirection and run your test scripts and whatnot, be my guest. Okay? In fact, I would do it like this. If you want to include all your tests and stuff like that, just to make sure that you can rerun all the test cases with your scripts and whatnot, I would do something like this. Whatever name you used for your test script, I just use your test.gdb here. This will, whenever you say make main.test, it will rerun your entire test suite, which can be useful. Are we still doing okay so far with this? So let's go check it out, okay? Let's check it out and see if it works. So I'm gonna make some changes here to main.c. So I'm gonna say, well, I'll do that. And I'll go into one more.c and change it back to just returning x plus 1, like so. And now I say, I want to run GDB again. I want to debug the program again. So instead of make first and then GDB main, I'm going to say make main.gdb, which is not something that it will actually create, but it triggers the rule to run GDB. But because GDB, the rule to run GDB relies on main as a dependency, it will force it to remake main, which in return will make it to recompile the source code as necessary. So let's double check. Okay, so let's see what it actually did. I made some changes to main and one more, so the .d files corresponding to those two source files got regenerated, just in case the change that I did has an extra pound include or something like that. And then the next thing it does is to recompile main into main.o. It recompiles one more .c to one more .o, the object files, and then it relink everything into main as an executable. And then it runs GDB main all by itself. And by the time I get to GDB, I don't have to worry about a single thing about, oh, did I recompile everything? Did I relink everything? Did I forget, that, oh, there's one more pound included in one of the source files? I don't have to worry about that single thing. Is the concept sinking in? I know there's a lot of details involved in the Makefile program. Are you guys confident you can make the changes that you need to get your project going? Okay, let's take a quick look at Makefile. What you really need to change is just the beginning of this code here. I can even upload this one, it doesn't matter to me. This structure will even work with your C++ programs. For those of you who are taking CISP 430 or 400, you won't have any C source or assembly source files. So lines 6 and line 10 will be empty. Just let them be, okay, it doesn't bother anyone. But what you do need to do is to expand on line 7, so you will have CPP files specified on line 7. And you will also need to have extra rules here. So instead of just having .c and .s, what you will also need is to specify .cpp, so that you can create the dependency file based on the .cpp or C++ source file. Yep.
Can you do a %.c on CSRC?
You cannot, because you mean here?
Yeah, take that, but as in the
No.
state files.
You cannot, because each rule can only generate one target. And when you use cisrc, it is a whole list of source files. It doesn't know that it's supposed to use the command for each item to create the target.
Would there be something equivalent to suggesting?
No, not. Unfortunately, there's no. Well, none that I know of. Okay. The way this works, to get to what you want to do, is the list is specified here. So obviously, if you have C++ source code, you will also need to extend this one here. So you have CCSRC : .cpp equals .o, just so that you are now relating the source files that ends with CPP to the object file. That's how you make that link. But as it is now, it should work with your C++ source code as well. So I'm going to ask you guys a loaded question. Why are we doing this when code blocks can do all of this without any command line, without any editing any source files?
Code blocks is like a GUI. It doesn't have it's like requires more power from the computer than the command line.
And sometimes you may not even be able to run it. Now imagine that you are a developer for Mozilla, okay? You're running, updating Firefox and stuff like that, okay? How do you think you're going to work, for the most part? When you're working from home, what do you do?
What do you mean?
Well, you log into the organization, right? To a computer in the organization.
Right.
There are multiple reasons why you don't want to take the source code with you, to your home computer. One, the environment may be different. Now, it's an open source project, so there's no secrecy, trade secret type of thing that you have to deal with. But you still don't want to do it because now you have the source code, on your home computer, and then you have another one, another set at work. And even though there are ways to make sure that they're consistent, it's still one more step that you have to take. Okay, so a lot of times you want to just kind of log into your office computer or whatever virtual machine they use, in the organization, and use that machine. So when you log in remotely, what do you use? Mostly SSH, okay, which is a command line interface. So there you go. I mean, you cannot run code blocks easily, which is not to say that you cannot run it. It's just not easily. Okay, you can run Firefox remotely, or any type of program you can run it remotely, especially using X Windows. You can basically tunnel through a X connection, and then on any computer you can run an X client that is running on another X server. So that can be done, but it does chew up more resources. And if you're just developing, most of the time you have specific test cases. You're not really just going to run Mozilla and hand test all the features. You are going to run a test suite on the executable and let the program do all the verification for you. So if you can just say make Firefox.test, and it will automatically go through all the test cases, and you just have to kind of sit back and wait for the test result to come back. Hey, why not? And I can also tell you that there are commercial projects out there that will just make use of makefiles instead of the whole GUI tool thing. So this does have applications in real life, even though it looks like, hey, that seems like a lot of trouble that we don't have to learn because we got GUI tools. Are there any questions about how we use the makefile in this case? I'm going to re-upload this particular makefile just because it is enhanced, to deal with CPP files. So I'm going to re-upload it here. Yep.
Don't you have to add the CPP files to the clean command?
Oh yeah, I forgot about that. But you guys get the concept, right?
Yes.
Yep. ccSRC .cpp close. Hello.
What is that INC for?
Hmm?
INC before signature
INC, it's not even here. It's an include file that we don't deal with at this point. So if it's empty, it doesn't really do anything. So I'm going to re-upload this file. Are there any questions? I mean, do you guys have any questions about the make utility program, or even how to? Yep, go ahead.
I'm looking at the homework, thinking about just what you're actually doing. You make those source files for Johnny.s and one more.s in assembly, and you are combining that with C code. So,
yes.
So you comment out the
so you have to
definition.
you have to comment out the definition in C, in main.c.
But it's still using a main.
Correct.
In C.
Yep.
Okay.
Yep.
We just come out the journey and one more function.
Yep. But you have to implement the function in assembly so that it will have the same effect as the C version. And we did not quite get to those concepts today, so that's why the homework is going to be postponed.
Another thing, you specify you can use and to step over a function call if that is what you want. Why would you want to do that?
Say that again?
You say you can use n to step over a function call if that is what you want, but why would you want to do that?
Because if you know that Johnny is working already, there's no need to trace into Johnny. You can just do an n and then continue on to the next line to test one more.
I see.
It depends.
Johnny can be really, really big, and you don't want to go in there.
Yeah, Johnny has 2 instructions in that subroutine, even in assembly. And we're gonna upload the make file.
INC journey only have return 5 in C.
Well, we haven't talked about it yet. You are more than welcome to read the text to find out how to do it. No, let me rephrase it. You are required to read the text to figure out how to do it. The text has it already. Yeah, the concept is already there.
The notes online.
The notes, all the other links in Moodle.
I mean, my question is, we are just return this journey and one more function. We put it on here and turn to assembly and then do and come.
You have to implement both Johnny and one more in assembly. So you're going to comment out the C code, implement in assembly, and double check that it still has exactly the same functionality.
What about the prototypes?
You have to have the prototypes. The prototypes are for the C compiler. The C compiler, without the prototype, and you say, x equals to Johnny open and close paren, the C compiler will complain because it can see that you want to make a call to a subroutine called Johnny. That itself is not an issue. The linker can resolve the unresolved reference. The question is, does Johnny return an integer value? I don't know. Does it require 1, 2, or 3 parameters? I don't know. That's, yeah.
I was thinking more just because it's an assembly. It's still same format for the prototypes.
In assembly, there's no such thing as a prototype. So the assembly source code does not have any actual prototype because in assembly, remember, we don't even have types in assembly. So there's no way to specify, hey, this subroutine is supposed to return an integer. Can't do that. So, okay, so this is the clue to do the homework assignment. This is a good document to read, C calling convention, but I would read it after reading parameters, local variables, and return value. And the whole thing about call frame, is also kind of useful too. So call frame, local variables, and return value, and this one, these are the things that you need to read in order to kind of get an idea of, how to get this homework how to get it done.
suggest that order to?
I would, just for this homework, I would use, that's a tough one. This may not be a bad one to start, okay? This is a Wikipedia page, but it does have the information that we need. It's just that it also has a lot of stuff that we don't need. So if you go to CDECO, go to 2.1, CDECO, this is the part that you actually need to know. So if you, okay, I'll just kind of read it. The recorder is still on. Okay, the CDECO, which stands for C Declaration, is a calling convention that originates from the C programming language and is used by many C compilers, including GCC, in the context of Linux for the x86 architecture. In CDECO, subroutine arguments are passed on the stack. Okay, so that's one thing. Okay, so you know the parameter x is passed on the stack. Okay, now how to access it is a whole different story. Okay, so that's why you need to kind of read the notes. Integer values and memory addresses are returned in the EAX register. Well, does that kind of help you implement Johnny? And that's why I said Johnny only has 2 instructions. Has one label, 2 instructions, and one .global, because you have to use the .global to make the linker know about the label Johnny. Okay, so that's one thing about Johnny that you have to remember. Registers EAX, ECX, and EDX are caller saved. In other words, when a caller calls a subroutine, the caller has to say, if I need to preserve the value of EAX because I got something stored that is useful in EAX, the caller is responsible to push it first, to save it so that it can be restored after the return. Okay, so EBX or all other registers that are not listed here are the responsibility of the subroutine. In other words, if you plan to use EBX in a subroutine, you are responsible to save and restore it so that from the perspective of the caller, EBX is not changed. So I'm just kind of reading on. You don't have to worry about the x87 floating point processor because we're not going to deal with floating point instructions. So this part here is not relevant to what we are doing. So just ignore this part here. In the context of the C programming language, function arguments are pushed on the stack in the reverse order. Not important in the context of your homework assignment because we only have one single argument, so it doesn't really matter. In Linux, GCC sets the de facto standard for calling conventions, so that's why what we learn in this class is really useful because even in Windows they still use this type of standard. Is that okay so far? And it has some sample code here, to illustrate, certain instructions. Except these are specified in the Intel notation, not the AT&T notation. So when you're dealing with add and subtract and move, the operands are reversed, and the way they express immediate is also different. So in this case, they don't need the percent for register, and to specify an immediate operand, there's no dollar. So that's why, when it gets to the actual assembly code, I would not read this part here because it can be confusing. But in terms of what you need to read in order to get the homework done, it would be just, all of this stuff here, local variables and return value. These two are kind of the same thing, except one is newer and the other one is older. And you can see that, I changed the way I wrote my notes. This is the module, which is a newer version. The other one is kind of a portion of a book, which is the older version. They have the same content, same concept, same content, just explained slightly differently. All right, are there any questions? The homework is not assigned yet, so don't push yourself to get it done, but I would definitely try to read the material ahead of time, so by the time we get to it on next Tuesday, you can get started with your homework right away. Okay, any other questions? All right, and Danny brought food.
Yes, would you care for a slice? They're skinny slices because the pizza had a large radius.
Let me stop the recorder first then.
Yeah.